Oh boy. All right. Sorry, we had a little baby situation there. Sounds like we're still having a baby situation. All right. I apologize. Had a little bit of a baby situation. She was not happy with us. So, that being said, we are doing today, we're going to have a lesson on sound. And we're going to use paper cup telephones as our means to teach about sound. And so, what you'll need for today, really the big things that you need two cups. I have paper cups. They tend to work better for this. But if you have plastic cups, those will work also. So two paper or plastic cups, like the disposable kinds. And you'll also you don't really need the paper clips, but I tend to use them when I make these, but you will need string, all right? So I have string that is, a ball of string. You'll probably want at least 3 feet worth of string. At least 3 feet worth of string. So again, you're going to need two cups. They can be paper or plastic. I tend to use paper. So if you have paper cups, those will work best. And then string. You need those two things for sure. Paper clips do help. At least I think they help. So if you have paper clips, you need two of them. All right. So I'm gonna let a few more people sign on, and then we'll get started. All right, I see my buddy Yasenka is on Instagram. Good to see you. We got the Coleys and the Star Jewels. Good afternoon. Good afternoon. I see you. Glad you could join us again today. So we'll go ahead and get started. I decided over the weekend I could do another week of lessons. And so today we're doing paper cup telephones, and we're going to talk about sound. I don't have the full syllabus posted just yet, but I'll work on that today and get the full syllabus for the next 4 days out. And if I extend it again next week, I will let you know sometime during the weekend. And again, glad to be able to do this. And I hope that I am helping, and I hope that you all, young people, are learning. And so we'll get started. Today, we are talking about sound. So, what is sound? What is sound? All right, make sure you have your notebook, and make sure you're writing in your notebook. All right, so write down the topic. The topic today is sound. I'll actually spell that out for you. If you don't know how to spell sound, sound is spelled S-O-U-N-D. All right? Sound. S-O-U-N-D. Sound. Okay, so what is sound? What is sound? Think about that. What is sound? Okay, maybe you can actually describe sound a little easier, right? So if I take my hands and I put them together, I made a sound, a clapping sound. I take my two fingers here and I made a sound, a snapping sound. In fact, I'm talking. You're receiving it as a sound. What other sounds are there? Do you play an instrument? Maybe you play the violin or the viola. It makes a sound. Maybe you play piano. It makes a sound. Drums. Drums make sound. Okay, what other sounds are there? Have you ever heard a car drive by really fast? It goes, that's a sound, right? What about, have you ever been to a body of water, a river, a lake, a pond, a stream, the ocean even? Does it make a sound? Yeah, you hear the ocean roaring, right? Sound. Think about that. Sound. I was once in an area where there were mountains and there was the ocean. And at night, I thought the sound I was hearing was thunder because thunder makes a sound. And it wasn't even thunder. It was the waves of the ocean crashing up against the shoreline sounded like thunder. Can you think of another sound? There's sound all around us all the time. I'm in a room right now, and in this room, I hear lots of sound because I'm paying attention to them. I'm in my kitchen, and there's a refrigerator behind me, and the refrigerator makes a sound. The lights, if you get close enough, you can hear them buzzing. They make a sound. All right? Sound is all around us. Hey, Auntie, I see you. So, how do I know there is sound? How do I know that there is sound? Think about that. Write your answer down. How do you know when a sound has been made? All right, I'll tell you. We have these wonderful things called ears. And with my ears, I am able to hear sound. Okay? Sound is a wave. It travels in a wave. This wave is not like when you wave hello to your friends. This is a wave like if you went to a body of water, like the ocean, and you saw the wind was having an effect on the water and it causes the water to have waves. It's like that. Sound travels kind of like that in waves, right? So that's how sound travels. It travels in waves. And what happens is when a sound wave like that is made, your ear receives it. So imagine your ears are just like a satellite dish stuck to your head. It's receiving sound waves, okay? And then your brain translates those sound waves into a sound that you recognize. And sometimes a sound that you don't recognize. If you don't recognize it, you'll say, I don't know what that is. But if you do recognize it, you'll say, it sounds like someone snapping. Sounds like somebody clapping. Or if you hear someone playing a piano, you'll say someone is playing piano because now your brain has been trained to recognize the sound of a piano. All right? So sound travels in waves. It's actually very fast. So if you're on an airplane travels, let's say it travels from the East Coast to the West Coast. So from New York City to Los Angeles, California. That airplane may be traveling at about 500 miles per hour. 500 miles per hour, which is very fast. But sound is even faster than that. Okay? So sound travels at a speed of, in physics terms, 340 meters per second. In normal people terms, that's about 760 miles per hour. Now, the speed of sound varies depending on the atmosphere in which it is moving. All right? What that means is sound travels faster or slower through the air if, in fact, it is humid outside or if the air is dry. All right? So, sound, write this down. This is really important. Sound travels faster in water than it does in air. And it travels even faster in a solid medium than it will in water. All right? So, the environment in which a sound is made has an effect on how fast it travels. Okay? So, today we will be using paper cups and some string to see if it is possible to get sound to travel from one cup to the other cup through the string. So here's what you'll need to do. First thing you'll need to do, take your cup. Notice there's no hole in the bottom of this cup. I'm going to put a hole now in the center of the bottom of this cup. I have a push pin that I can use, but you can also use, if you do have a paper clip and your cup is not too strong and fortified, you can actually poke a hole with the paper clip. Like I've kind of undone this paper clip a little bit, and you can poke a hole through the bottom and clear out enough space for your string. All right. Or you can use the push pin. So you'll need some way. In fact, if you have a pencil tip or an ink pen, that should work fine too for paper, and it may also work for plastic cups. But again, I'm using paper cups because I think I get the best results out of paper cups. So that's the first thing you'll need to do. The next thing you'll need to do, sorry, here, you can see I poked a hole there. You don't want the hole to be very big. You want the hole to be big enough for your string to go through it. All right. So how big you make the hole depends on how big or how thick your string is. This is the string I'm using. I think this is actually for those people who spend a lot of time cooking in the kitchen. This is like the kind of string that you would use to tie up the ends of a chicken. You're roasting it. So that's what I'm using here. And again, probably would help if you had scissors. I would recommend, if you have a ball of string like I do, using 5 feet or more of string. Okay, 5 feet or more. Once you have your amount of string, what you'll need to do is take the string and force it through your hole. Now, this may take a little while. I did this earlier today, and here we go live again. We will find out if the live camera will be as friendly to me as it was when I was doing this earlier today. All right, so what I'm going to do is I'm just going to kind of twist this string a little bit because it'll be easier for me to force it through the hole here. At least I think it will. All right. And you want your string to go all the way through the hole. And you want to pull that end out and through. Of course, this doesn't want to be friendly to me now. Butcher's twine, that's right. I see you, Myron. All righty, so I'll try this a second time. If I can't get it to work, what I will do is show you what I did earlier today, and hope that suffices for you, and you trust that I'm telling you the right things to do. Aha! All right, I think I got this string to go through. Yeah. Okay. Okay, once I get some of it through, hopefully if my hands are able to fit in the cup, I can pull it through. There we go. Okay. I thought I had it. force it through a little further. Butcher's twine may not be the best for this demonstration, but it was cheap. And there was a lot of it. All right, there we go. Okay. Now, the reason I recommend, at this point, you can pull the string all the way through. And when you pull the string all the way through, like I've got the string all the way through, you can actually tie a knot. And you'll have to tie a knot, okay? This is why I say you don't need a paper clip. But I tend to use paper clips. And what I do is I actually just take the string and tie the knot around the paper clip. I think that adds a little more weight to it and makes it a little more effective to work with. You can store it, you don't have to worry about tying the knot on the string, but the knot on the string also works. So you don't need a paper clip to make this work. You just need to be able to tie a knot. All right, so I'm gonna tie now a knot around the paper clip towards the end of the string. I don't need a lot of the string hanging off, extra string hanging off. All right, I'm so proud of myself for getting that done live. All right, and then what I do next is I take the string and I just pull it all the way through. So you can see now my paper clip is in the bottom of the cup. Paper clip's in the bottom of my cup, and I cheated a little bit. I did this also earlier on the other end. That way I didn't waste a lot of time on live camera. So I have here two cups with string pulled through the bottom. And from there, we have what we need in order for this to work. But here's the catch. A lot of times people do this, and I want you to really pay attention to this. Pay a lot of attention to what I'm gonna say. People will put string through one cup and string through another one, put the knot in it. They've got their paper cup telephones. But you know what they do? They talk into it, and on the other side, the person can't hear. And the other person tries to talk into it, and this person can't hear. And the reason is because they have the string like this. You need, in order for this to work, your string needs to be fully stretched and tight in order for you to hear and hear somebody speaking on the other end. If the string is sagging, it won't work. Why not? I won't get into the nitty gritty of it, but it has to do with the physics of how sound travels. Remember, I said that sound is traveling as a wave, okay? And if your string is already bent like that, that is a bigger wave. And what ends up happening is the sound cannot travel as effectively. And this is just a very elementary way of describing it because there's a lot of physics that goes into the concept. But really, the wave of sound can't travel as effectively from one cup to the other cup if you already have a big wave that it is a part of. And believe it or not, we consider this a part of a wave if the string is sagging. So what that means is you need to have your string tight. So what I recommend if you want this to work is one person grab the cup and that person stands still. The other person walk slowly away until the string is taut, T-A-U-T, taut, or really tight, all right? Once the string is taut, then one person can speak and the other person can listen, and you should be able to hear clearly, okay? So I do have some questions about that, though. What if the string is 5 feet long? Can I hear from one end to the other? What do you think? The short answer is yes. I kind of implied that in the length of the string that I said you should have. All right. What if the string is 15 feet long? Okay. So think about maybe a long truck or a van, 15 feet long. Will the string, if it's pulled tightly and someone's speaking from one cup to another cup, will the string allow sound to travel from one cup to the other clearly enough for me to understand what's happening on the other side? What do you think? Okay, the answer is yes, it will. Next question. What if my string is 30 feet long, okay? And I am speaking on one end and there's a person on the other end. Can the person on the other end, the string is tight, can the person on the other end hear what I'm saying? So imagine if I was on a school bus, the front of the school bus all the way to the back of the school bus, and there's a string that's pulled tightly, and there's a cup on either end, and one person speaks and the other person is listening. Can the person who is listening hear what is being said from 30 feet away? Well, I have tried this, and I have news for you. It, in fact, works. Okay. What if the string is 50 feet long? 50, that's 50 feet long. What if the string is 50 feet long and it's pulled tightly, and there's a cup on one end and there's a cup on the other end, and the person on one side is speaking into the cup and the person on the other end is listening? And can you hear that far? The person who's listening, do you think they can hear what is happening 50 feet away? What do you think? Okay, I have tried this, and I have to tell you, it works. In fact, if you whisper 50 feet away and the string is pulled tightly, you can actually hear the whisper. Okay, what does this tell us? This tells us that sound travels very well through this solid, what we call medium of the cups through the string. Now, how does this work? Basically, the cup is serving a dual function. When someone is speaking through the cup, it is functioning as the microphone. When someone is listening on the other side, it is functioning as a receiver. Okay, so the cup itself actually functions as both the microphone, where you send the sound through it, and the receiver, where you receive the sound from it. Pretty cool. So the cup itself is serving a dual function, which is pretty awesome. So, next question. What if the string is 100 feet apart? 100. So I said it works at 5, it works at 15, works at 30, it works at 50. What if the string is 100 feet apart? Will it still work? What do you think? All right, I have news for you. I don't know. I've never tried 100 feet. I've tried 60 feet, and it definitely worked at 60 feet. Now, there is a length at which it will no longer travel, but I've never tried 100 feet. Maybe one day I'll give it a shot, measure it out, post it on YouTube or something, and you all can see the results. But I do know at 50 feet, it absolutely works. Okay? So sound is very impressive. This wave, it can travel very fast and very far. I mentioned before that sound is 760 miles per hour, but an airplane, typically a commercial flight, will travel like 500 miles per hour, give or take maybe 50 miles per hour. So there are planes, however, that are what we call supersonic. Supersonic. I'll write that word down for you just so you can see it. So supersonic, that means that the airplane is traveling faster than the speed of sound. Supersonic. So about 20 years ago, there used to be these commercial airplane flights they would go, for example, from Paris, France to New York City, or from New York City to London, England. And those flights were on this airplane called the Concorde. There was a fleet of Concorde airplanes, and they traveled faster than 760 miles per hour. They were supersonic. The military has airplanes that travel twice the speed of sound. Okay, that is very fast. There have been some cars that people have made almost as just an experiment. Can we do it? They go faster than the speed of sound. Okay, supersonic vehicles. They can go faster than the speed of sound, which is very, very fast. But it can be achieved, okay, by certain objects. I want you to know, this is just an important note to make. The fastest thing that we know of is light, okay? Human beings can create devices that allow us to go faster than the speed of sound, but it is theorized there is nothing that we can do to get us to go faster than the speed of light. Light moves way, way, way faster than sound. Okay, just Don't want you to be confused about that. Speed of sound is very fast, but we can go faster than the speed of sound. The speed of light, we cannot go faster than the speed of light. All right, I think that is all I intended to cover today for sound, and I hope that you have some paper cup telephones. Oh, I did want to ask another question. I do have another question for you. What if I have my paper cup telephone, and on one end I have my cup, and on the other hand I have the other cup, and the string is really tight, and then someone comes along and they pinch the string right in the middle? What will happen to the sound? If somebody is talking, can the person who is listening still hear it? If someone's pinching it? What if I have the string wrapped around a corner of the house? Can someone still talk and be heard on the other end? What do you think? What's your hypothesis? Okay, I have an answer for you. If someone pinches that string, it will dampen the sound. I'll write that word down for you. It will dampen the sound, okay? Okay, so if someone pinches the string in the middle, it will dampen. That's D-A-M-P-E-N. Dampen the sound. And it may cut the sound off altogether. You are breaking the path through which the wave travels. All right. So dampening the sound will occur if you pinch that string or if it's bent around another solid object like the corner of a wall. So if I tried this, I put a telephone that was 30 feet long, string was 30 feet long, I have one cup in one bedroom, and I tried to wrap the other end around the corner of the hallway to get into another bedroom, your chances of hearing the sound on either end are very limited because you've likely dampened or cut off the sound completely. All right. So I hope you made your paper cup telephones or plastic cup telephones. Again, this does work with paper or plastic. It just tends to work, at least I found it work better with paper cups. But if you have done that, give it a try. Find a sibling or a parent or a friend and maybe make one that's 10 feet long. Don't talk too loud into it. Just talk normally into it and see if the person listening can actually hear. If you're yelling into it, of course they'll be able to hear, but they'll be hearing from the outside. Just talk quietly into it. Whisper even. See if someone can make out exactly what it is that you are saying. All right. Again, if you want to post pictures of me that I can see of you trying this, definitely hashtag it Science Made Simple. Okay. And I should be able to find it. Also, I'm on Instagram at ScienceMadeSimple_LLC. And I have a YouTube channel. Just search for Dr. Boyd, the chemist. And I try to do some fun experiments and fun science. I posted another video last night of me having some fun with some candy with my niece and nephew. I hope you find that video enjoyable. It was delicious and I hope informational. All right. Thank you so much. And I will see you tomorrow at 2 p.m. Bye.